All right, time for video 2. And let's look at a few more examples. First one we have is the square root of 48. So ask yourself, what numbers can you multiply to get 48, where one of those numbers is a perfect square? And the first thing I think of is, well, that's the same as 16. 16 times 3. I can take the square root of 16. That's a perfect square. So that'd be, the square root of 16 would be 4. And I'd be left with a square root of 3, so 4 square root of 3 is the correct answer. Okay, 72 times x squared. Well, the first thing I think of there is, I think of the square root. I think of 9 times 8. And remember, when we have variables that have a exponent, we want to pull out the greatest even one that we can. So we're going to say that's the same as x to the 4th times x. Where are my perfect squares at? I have a perfect square there and a perfect square there. So I can pull out a 3 because 3 times 3 is 9. And I can pull out a x squared because x times x, or x squared times x squared is x to the 4th, so x squared. And that leaves me with the square root of 8x. And actually, in this one, we are not done yet, because if you look at it, I'm going to change this color so it makes a little more, nope, I should have just left it alone. I'm pulling out a 3 there and a x squared there. If I look at this a little bit harder, x to 8x, the square root of 8x, 8 is not a perfect square, but can't I make 8 out of 4 times 2? Yes, I'm going to rewrite this as 3x squared times the square root of 4 times 2 times x. So you really have to look at these guys. When you have an answer, you might have done all the steps correct, but just like when simplifying fractions, once you're done, you need to go back and say, wow, is that simplified as far as I can go? Here, this is not simplified as far as it can go. I can pull out a 2 because 2 times 2 is 4. So that would go out there. So that would be the same as 3x squared times 2 times the square root of 2x, because those are left on the inside. And well, 3 times 2 would be 6x squared times the square root of 2x. So, are there a lot of steps here? Yes, but I think you guys are fully capable of this. If we look at 125b to the 4th, well, the good news is 125 is the same as 25 times 5. And b to the 4th is already to an even power, so that'll make that really easy to take the square root of that. The square root of my perfect squares I'll take first. I know I can take the square root of 25, so I'll, wrong thing. I know 25 is a perfect square, so I can take the square root of that. And b to the 4th is a perfect square, so I can take the square root of that. The square root of 25 would be 5. The square root of b to the 4th is b to the 2nd. And if you guys haven't noticed yet, we really just cut them in half. Not with our whole numbers, but with our variables with a exponent, we just cut that in half and take the square root of it, times the square root of 5. And that would be my final answer on that example right there. So 3 more examples of how to do these. Let's look at a couple more examples, and these will get a little bit harder. I say they don't get any harder. Do they look harder? Yes. Are they actually much harder? No. So now I have a coefficient on the outside of this one. It says 7 times the square root of 128m to the 5th. If you already have a coefficient out here, just leave it at the beginning. Okay, just leave it. So I'm going to rewrite this as 7 times the square root. Okay, how can I break 128 down? Well, that's the same as 64 times 2. And remember, with our variables with an exponent, we want to rewrite it leaving the greatest even exponent possible. So I'm going to rewrite that as m to the 4th times m. Now I look for my perfect squares. That'd be 64 and m to the 4th. So I'm going to take those out and pull them out. So I'm going to rewrite this as 7 times, well, the square root of 64 is 8. The square root of m to the 4th is m squared. and I leave everything else inside of my radical. And so then I do 7 times 8 is 56 m squared times the square root of 2m. And that is the answer to that one right there. Okay. Next one, I have 4 times the square root of 305 s to the 5th t to the 8th. So, once again, if you have a coefficient, just leave it on step 1. We're going to leave it on the outside. I'm going to rewrite what's inside my radical. 300 is the same as 100 times 3. Why did I pick 100? Well, because it's a perfect square. If you use 150 times 2, you're not going to help yourself out at all because 150 is in a perfect square and 2 is in a perfect square. With my s to the 5th, I'm going to rewrite that as s to the 4th because I want the greatest even exponent that I can leave, times s times, well, t to the 8th is already even, so I can leave the s t to the 8th. So I'm going to go through and find my perfect squares, which are all right there, and I'm going to take those and I'm going to pull them out to the outside of my radical. So I'm going to be left with 4s times, well, the square root of 100 is 10. The square root of s to the 4th is s to the 2nd. And the square root of t to the 8th is t to the 4th. And once again, I just take those exponents and cut them in half, times the square root. And what's left on the inside? Well, it's my 3 and my s. So now I just simplify what's on the outside of my radical. 4 times 10 would be 40. S times s squared would be s to the 3rd. T to the 4th, all times the square root of 3s. And that would be the answer to that one right there. Don't want to stop that quite yet. All right. And we'll do one last example for this video. 2m to the 3rd n to the 5th times the square root of 121 mn to the 9th. So, step 1, leave the radicals the way they are. No reason to deal with those quite yet. I'm going to rewrite my radical as a product of perfect squares. 121 is awesome because it's already a perfect square. M, you really can't do with that. You can't take the square root of m, so we'll just leave it as times m. I'm going to break n to the 9th down to n to the 8th times n because I want to leave the greatest possible even exponent that I can. I'm going to highlight my perfect squares. I'm going to pull those to the outside of my expression. So I'm going to be left with 2m to the 3rd n to the 5th times the square root of 11, or the square root of 121 is 11. The square root of n to the 8th is n to the 4th times the square root of m to the n, because those are left on the inside. 2 times 11 is 22. M to the 3rd times, no m, so it's just m to the 3rd. And n to the 5th times n to the 4th would be n to the 9th times the square root of m n. And that would be the answer to that example right there. So